Hi friends, good evening. This is Professor Prashant Manjrekar. Now, this is one new video. This is something how to complete physics portion in 1.5 day. Now, practically thinking, this is very difficult. Now, but you can't do anything for this. You have to utilize this time in a proper way, proper productive way. For that, I am giving these tips, say 10-15 days before your exam starts. Now the tip says कि if you are starting with first chapter, say first chapter is force. In this first chapter, you have to start with first, that is theory part will discuss one by one with a numerical sum part. Some numerical special videos I will provide you, don't worry about that part, but today we'll do only theory part. Now first chapter, the first question they can ask, what is the effect of force if the body is free to move and if the body is pivoted? Now if the body is free to move, then you have translational motion, but if the body is pivoted, it is a rotational motion. Now second topic over here, what is the moment of force? So definition they can ask, SI unit of moment of force, then whether it is scalar or vector, it is a vector quantity because it requires direction. Now when you have anti-clockwise movement is considered as positive, clockwise movement is considered as negative. Then they can ask a application based question like why screwdriver has a long handle, why door has a hinge, why door has a handle at its other end apart from hinges. All that part they are based on the principle of moments where it is the product of force into perpendicular distance. So if you increase the perpendicular distance, force will decrease. Now next part will be what is a principle of moments. Principle of moments is in equilibrium total anti-clockwise moment is equal to total clockwise moment. Beam balance is an example of that principle of moments. Now this is about part A. There is one more term called as what is equilibrium. Equilibrium is what if number of forces acting on a body produce no change in state of rest or state of motion, the body is said to be in what equilibrium. Now there are two types of equilibrium, static equilibrium and second will be what dynamic equilibrium. Now static equilibrium, all examples they can ask and also they can ask example of dynamic equilibrium. Now textbook kept on a table, any object kept on a table is example of static equilibrium. But dynamic they can ask raindrop falling from clouds, we can see aeroplane is moving at certain height, then satellite is revolving around the earth. All these are example of dynamic equilibrium. Electrons are revolving, all example of dynamic. This is about part A. Now these are theory questions, main theory questions. They can ask question on that part. In part B of first chapter, they have a definition of center of gravity. Now center of gravity definition is a big statement. You have to do that statement as it is. You can't skip in and out, whatever it is, you have to do as it is. Now they can ask question on that, define center of gravity. On what factor center of gravity depends? Center of gravity depend upon the mass, how the mass is distributed, how the shape of the body, size of the body, all that part. They can ask the question, what will happen if the body is deformed? Deformation is what? Change in shape or size or both shape and size of the body. So if the body is deformed, the position of center of gravity will automatically change, due to which what will happen, if the position of center of gravity will change, then definitely if the shape of body change, the position of center of gravity will automatically change. Then is it necessary that position of center of gravity is within material of body? No, it is not necessary. There are some bodies where center of gravity is not within body, it could be outside also. Ring, hollow, sphere, all that part. Then they can ask that there is a one table in which there are 7 to 8 quantities where they can ask the position of center of gravity. So they can ask find the position of center of gravity of scale triangle or that part in that question. Now the part C. Now part C says that there is a distinguish between uniform linear motion and uniform circular motion. Now basically what is linear motion? Body is moving in a straight line path. But what is circular motion? Body is moving in a circular path. But there is a difference between uniform circular motion and circular motion. In circular motion, body is moving along the circular path. But in uniform circular motion, body is moving in along a circular path with a constant speed. then it is called as uniform circular motion. Now the very first question in this part ki why uniform circular motion is called as accelerated motion. So in uniform circular motion, speed is same but velocity is different at different point. Now this velocity is always tangential to its path, therefore it is called as uniform circular motion, is called as accelerated motion. Now the next question in this part will be what? Distinguish between centripetal force and a centrifugal force. Now centripetal is a force, you can say definition says, is not given in a book, but you can write is that for a particle performing uniform circular motion, the force which is directed along the radius and pointing towards center is called as centripetal force. But for a particle performing uniform circular motion, the force which is directed along the radius but pointing away from center is called as centrifugal force. Now centripetal force is a real force. Now why it is called real force? Because it is due to some known interaction, therefore it is called real force. Cause is known, therefore it is called real force. But centrifugal force is a false force, pseudo force, because it is not due to some known interaction. Now third point is not given in a book. It is required. Centripetal force is required for uniform circular motion, but centrifugal force is the effect of uniform circular motion. Centripetal is required and centrifugal is the effect. Now the next part will be what? It is a distinguish the examples of a centripetal and centrifugal force. Now example of centripetal is what? Ki satellite is revolving around the earth. That satellite is revolving around the earth is the necessary centripetal force is provided by the gravitational force of attraction between the sun and the satellite. Similarly, you can apply it for planets. The planets are revolving around the say sun. The necessary centripetal force is provided gravitational force of attraction. So you take a stone whirled in a circular path, then the tension in the string provides the necessary centripetal force. Now the next part, electrons are revolving around the circular orbit. The necessary centripetal force is provided by electrostatic force of attraction between negatively charged electrons and positively charged nucleus, that is proton. Now examples of centrifugal is a centrifuge machine, merry-go-round, washing machine, bulging of earth. All these are examples of centrifugal force. So this time they can ask the question, okay, distinguish between centripetal and centrifugal. Now this is about the theory part of chapter 1. Now in this chapter, the numericals part, I can say in first part they can ask, they can give you a moment of force value, that is torque value. They can give you force ka value and they can ask find the perpendicular distance. So when you solve any numerical, just take care that you are writing units properly. If it is a force, then check whether that force is required in kgf, gf or in Newton or in SI unit. Now in this chapter it is not necessary that you have to convert all numerical, all the units in SI. So you can say, they are saying ki force F1 is in kgf, distance is in centimeter, and other force is given as F2 in kgf also, and they want distance L2. So here no need to convert, you can write according to principle of moments, torque 1 is equal to torque 2, so F1 into L1 is equal to F2 into L2. Now some numericals from this chapter says if they are based on the principle of center of gravity. So they can ask a question, you have a uniform meter rule. So just take care whether it is a meter rule or half meter rule. So if they ask 1 meter rule, then you take a distance as 0 to 100, that is total length. 50 centimeter is the center of gravity, which is fixed, you cannot change. So 50 centimeter mark is the point where whole weight of the body is balanced, that is the mass, where entire weight of the body is balanced. So that is one point. Second, if it is half meter rule, that is 50 centimeter is the total length, then the center of gravity will be at 25 centimeter mark. Now they can ask the question, suppose F1, L1, F2, L2, they are given. They will ask whether this scale is in equilibrium or not. So at that time you can't write directly by looking at the values. You have to solve. Total anti-clockwise moment is equal to this much. total clockwise movement is equal to this much. Write the units properly, and then you decide whether torque 1 is greater than torque 2 or torque 2 is greater than torque 1. Then you can say it is not in equilibrium, it will turn clockwise or anti-clockwise. Now friends, this is for this chapter 1. The next chapter will be on work, and then we'll go step by step all chapters. Thank you.